Question 3, Part C. The diagram shows a point P which is 30 kilometers due west of the point Q. The point R is 12 kilometers from P and has a bearing from P of 070 degrees. Part 1. Find the distance of R from Q. It is given that point P is due west of point Q. That means point Q is due east of point P. So the bearing of point Q is 090 degrees, and that means angle NPQ is 90 degrees. Now the bearing of R from P is 070 degrees. That means angle NPR is 70 degrees. Now the sum of these two angles, angle NPR and RPQ, are adjacent and complementary since they add up to 90 degrees. So angle RPQ is 90 degrees minus 70 degrees, which equals 20 degrees. Now I've completed triangle PRQ by joining point R to point Q using a dashed line. So in triangle PRQ, we have two known sides and an included angle. Hence apply the cosine rule to find the distance RQ. So using the cosine rule, RQ squared is equal to PR squared plus PQ squared minus 2 times PR times PQ times cos of angle RPQ. And that equals 12 squared plus 30 squared minus 2 times 12 times 30 times cos of 20 degrees, which evaluates to 367.421313. Now to find RQ, we take the square root of this value here. So RQ is equal to 19.168233709, which rounds to 19.17, correct to 2 decimal places. Therefore, the distance of R from Q is 19.17 kilometers, correct to 2 decimal places. Part 2. Find the bearing of R from Q. Point P is due west of point Q, so the bearing of P is 270 degrees. To find the bearing of R from Q, we take the bearing of P, which is 270 degrees, and add on angle RQP, and that'll give us the bearing of R from Q. In order to do that, we can either use the cosine rule for unknown angles or the sine rule. Since we have three known sides, we found RQ in part 1, which was 19.17 kilometers, and we have angle RPQ, which is 20 degrees. I'm going to use the sine rule to find angle RQP and then add that on to 270 degrees to find the bearing of R from Q. So using the sine rule to find angle RQP, since there is a known side angle pair in triangle PRQ, and we know that point P is due west of Q, hence the bearing of R from Q is given by 270 degrees plus angle RQP. So using the sine rule, sine of angle RQP over 12 is equal to sine 20 degrees over 19.17. Rearranging the formula to make sine angle RQP the subject, we get sine of angle RQP is equal to 12 times sine 20 degrees divided by 19.17. Taking the inverse sine of both sides, so we can isolate the angle, we get angle RQP is equal to inverse sine of 12 sine 20 degrees divided by 19.17, which evaluates to 12.36 degrees, correct to 2 decimal places. So 270 degrees plus 12.36 degrees is equal to 282.36 degrees. Therefore, the bearing of R from Q is 282 degrees, correct to the nearest degree.